everyone. Sorry it took us a little time to get all situated when you only have 10 minutes to set up after Kevin's presentation. Thank you to our online participants, if there's anybody actually watching us. Thanks. It's good to know. I'm Jaclyn Russell, and this is Wilma Hashimoto, and we work here at AIM, Center of Math and Science, and we are actually housed on FPU. So this is where we work every day. So it's pretty awesome. At our site, we are research associates, and we're on the early math team. So it's Wilma and I, and then 3 others on our team. We work with preschool kiddos, and we work with the teachers as well. Want to go ahead and add a little bit?
Yes, so we're really excited in doing the research, and we wanted to make sure that we shared this out far and wide, is that, you know, there's a great push, right, to have children reading by 3rd grade. And the rationale is, right, people are basing the number of prisons if the child is reading on grade level by 3rd grade. So literacy, it's really easy to pick up a book and read to the students, and early learning teachers, they got it, right? And what's the front of the book, the back of the book, and so, but the research is now coming out that if you introduce and you're intentional about early learning math in preschool, that it would change the trajectory to having twice as many students to be on grade level, reading on grade level by 3rd grade. So do it in tandem, the early math. And so we're going to have some of these activities to introduce to you. Everything is probably already in your classroom or very accessible or easy to make, so that you're intentional in terms of what you observe in teaching and the questions that you'll be asking in terms of introducing math to your young students.
Note to self, don't put down the clicker. Okay, so what's so special about spatial? So that's our whole topic today, is spatial reasoning, but why? What's so special about it? So on your table, you have a yellow piece of paper, and this is for you. This is for you to keep. And I just put some pencils down. And if you can just take a minute or 2 and just write down some thoughts about what does spatial reasoning mean to you, why do you think it's important, and what words do you associate with spatial reasoning? And our online participants, feel free to just think of a couple, because we're going to discuss them in a second. So go ahead and just take a minute and just write down your thoughts, and then we'll go over them. And I just want to mention right now for our online participants, if you want to go ahead and tweet us, feel free to. We will answer. I'll check my phone periodically, and then we can also, throughout the day, check Twitter, and we can answer any questions or comments. And that was at hashtag AIMS Spatial, AIMS and SPATIAL. So does anybody want to share, what does it mean to you? If someone says, oh, that's spatial or spatial thinking, spatial reasoning, what does that mean to you? Maybe in your classroom or your kiddos? Oh, there you go. In the activities? Before, when I was a kindergarten teacher, when I would think of spatial, I would think of directions. And I would think of my kiddos with their positional words. I'm sure that's what some of you have in your classroom. Yes? Area around the object, or how the object fits together. That's perfect. And when you think of spatial, you think of that object in space, or you in space. Wonderful. And how about, why is it important? What did some of you think about that one? Why is spatial important for your kiddos, for you, for your classroom? Yes, that personal space. And I think that's what we really want to highlight in our presentation, why it's so important. So, the United States is known for putting a strong emphasis on reading, writing, and arithmetic. And we know that as people in the United States and as once students and in our own classrooms. I know that. But then spatial has so much significance, and it is in our everyday lives. And spatial reasoning, spatial thinking can be taught in early childhood education, and it's the perfect place to teach it. Spatial reasoning is definitely done through play, through that hands-on. And I think that is so perfect for our classrooms. If our kiddos leave us pre-K, K, and they go on further, and if you've given them those rich experiences with some spatial aspects as a grid, blocks, right, positional words, they're going to carry that with them for the rest of their lives and on to the next grade levels. So it truly is important, and we would love to see more of it in classrooms. And we're research associates, so we've researched this topic on, and the data we found is really mind-blowing. So what words do you associate with spatial reasoning? Does anything come to mind to you when just like one word is said? Say that again, I'm sorry.
Critical thinking.
Critical thinking. Yeah, problem solving. Perfect. And for critical thinking, you kind of have to have something like that image in your mind, right? For that critical thinking, you're kind of doing like a play-by-play in your mind. Visualization, imagery, that's all spatial. That's wonderful. I think positional words, being a kindergarten teacher, our assessments were a math assessment for the children to identify what is above, below, behind, beside, in between. All those words, all that language is very spatial. And language in general is extremely spatial.
So, as Jaclyn had mentioned, we introduce it while they're young because fast forward as adults, we'll be using that spatial relationship and reasoning. So, how many of you have actually tried to move furniture in a room and tried to, right, you had that little piece of paper and you're sketching out the couch looks good here, and then you realize when you tried to move that, you thought the size of a love seat was actually a large sofa, that it didn't quite fit into the space, right? So that is, again, spatial reasoning. For children, like we work with 3- and 4-year-olds, it's a matter of looking at a puzzle piece and then trying to figure out, okay, where's it going? They know it, and perhaps they need to rotate it or slide it or flip it. So those are the kind of skills that we need to introduce. And that's a good thing, actually, because I'm sure you get the questions a million times when parents come in and says they look like they're just playing, right? But really, there's some critical thinking going on there. We're going to show you in just a moment. How many of you are familiar with the show Friends? Yes. Okay, great. So in setting this up, Ross, many of you can remember this, Ross just bought a couch, and he wants to move it upstairs to his apartment. He enlists his friend, Rachel, to help move it. And when that doesn't go well, it goes a little sideways, he has Chandler, their friend. And so I want you to go ahead and watch it with the lens that Ross is the teacher of the classroom, and Rachel and Chandler are students, and the comprehension of, that how you receive information and give directions may be just a little off. So are you able to see it back there? Okay, great.
I clicked.
Ross, didn't you say that there was an elevator in here?
Yes, I did, but there isn't. Okay, here we go. Okay, go left, left, left.
You know what? There's no more left.
Oh, okay, lift it straight up over your head. Straight up over your head. You can do it. You can do it.
Oh.
Okay.
Oh.
You got it?
Yeah.
Good.
Oh.
Yeah, you got it, right? You got it, right? You got it.
Any chance you think the couch looks good there?
Just follow my lead.
Okay.
Come Come on, Chandler. Oh. Ah. All right, okay. Here we go. All right, ready? Yeah. Turn. Okay. Turn. Turn.
I don't think we can turn anymore.
I just don't think it's gonna fit.
Oh, yeah, it will. Come on, up, 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 up. Up. Yes. Oh. Here we go. Pivot. 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 Pivot.
Shut up! Shut up! Shut up!
Okay, I don't think it's gonna pivot anymore.
You think?
All right, let's bring it back down and try again.
Okay.
Oh.
Okay, yeah, I think it's really stuck now.
I can't believe that didn't work.
I know, me neither. I mean, you had a sketch.
Oh, you know what did you mean when you said pivot?
I've probably seen it at least a half dozen times or more, and I just laugh just as hard every time. Okay, so what did you notice in that clip that you could apply in your classroom? Yes? That's right. So for our online audience, what she said was she noticed that when the child has a puzzle piece and they kind of manipulate it until it can't go any further, and they just said, done with the puzzle, going on to something else. Anything else? Using language that they would understand. What we thought and what Ross would think in terms of pivot, he kept shouting out the word pivot. Chandler had no idea what pivot meant. How many times do we use words that we think the child understands, but really not, and they're kind of looking around, or maybe they do their own thing. So kind of checking for understanding there too. What else?
Yeah.
Teamwork, yes, and probably learning from each other. That would be helpful. And then you saw some prepositional in terms of, or positional words like, go lift it up, below, go sideways, turn left until there's no left. Mm-hmm. But as adults too, we go into spatial reasoning, and we see that children, right, when they build things, they have an image of what they want. And so when it said team building, I think when we have 3 children, sometimes the 3 children do not have the same image in their head, but they're working together, seeing how things work and how it fits together. Also, too, those are pattern blocks, which I think most classrooms have. The other one, I believe it's either cut out foam or construction paper. But we used the pattern blocks, and what we did was we actually created an image and had the children replicate it. So we would say, place the yellow hexagon, so we're teaching shapes at the same time, in the middle. On top, you would place the red square for the head. What we found is if the children actually have a specific image in their head, instead of just a design, it made it much easier so they could replicate it. But spatial reasoning is much more than just directions. It's also parallel parking, right? Having to know but the angle to go in, the angle to go forward or pull in, or some of us might just say, I think I see a parking lot at the end of the street there and go there with a bigger space. The other thing is, right, we talk about space and maps, and all of us, we all have GPS, and it's like in 0.3 miles, make a right-hand turn. But you're wondering, is that the street that you see next? Or is the next, how far is 0.3 miles, right? Why can't they just say at the end of 2 blocks or at the signal light? So that's the type of, you have to gauge that. And of course, when packing and unpacking, we have this as arriving and, it's all packed up, and then as you leave, it just may not look all the same, how it fit in one time, it didn't quite fit when you left. And of course, gauging that critical thinking, For instance, to come here, and I imagine you're on your summer break, you had to arrive fairly early this morning, right? And you may have come from very far. San Bruno was one place, the other place was Riverside. So you had to calculate, perhaps last night, how long will it take me to get to Fresno, specifically Fresno Pacific? Let me back map this. I would have to have so much in terms of driving time to get ready, and then also making sure to set the alarm that I get up and get here on time. So sometimes, if you don't quite back map and calculate the time, you're going to be running to get to your site, otherwise you're going to be late for work. So that's the type of critical thinking or spatial reasoning that it encompasses. All these different things, whether you're a child at 3 or 4 or as an adult.
And the research side of this, not just in our everyday lives, but Nora Newcomb, she's known for her Spatial Intelligence and Learning Center, and we've really studied her closely. And she describes spatial ability, spatial intelligence, as being able to understand diagrams, maps, charts, but also to mentally manipulate objects in your mind. So if you think of an equilateral triangle, and you can picture that equilateral triangle in your mind, because we all know what that looks like. And if I asked you to rotate it in your mind by 90 degrees, well, we can all do that because we know through our experiences in life what a triangle is and 90 degrees. And so when we transfer that into children, into early childhood, when they are using the pattern blocks and they are trying to build that image, they like to call them a robot, they would have to move those shapes to that place and then move them around and try to get them to fit because they don't have that mental image yet.
Is this the band one? Okay, so we actually have another very quick video, and we want you to take a look. How many of you were actually in a band, marching band? Very good. So with spatial reasoning, you have to know where you are to the next person, right? Because when you're on the field, everyone's the same height, and you really don't see the pattern that it creates when you're about, 200 feet high or, row J or something. So we want to amaze you with the Ohio State Band, who actually made a tribute to Michael Jackson. So take a look at it. You'll see the moonwalk, and also want to call out there's the white glove on the top right-hand corner.
With the pride of the Buckeye.
Wow, yeah.
I think. And so in that clip, if we showed it to you before, would you think, oh, spatial reasoning, spatial thinking, spatial abilities? No. But we tried to really find a clip that exhibited everything like that. And so their body movement, we had that aerial view. And for them, think of all those hours, right? And I'm thinking college students, all those classes, oh my goodness. And so with them, they were doing embodied cognition. And their bodies were moving, and they had to know where their body, their being was in space in relation to others and to other objects. And through that embodied cognition, through that movement, they were learning where to go through their practice. And so, Wilma, embodied cognition?
Yes. So embodied cognition, that's a big old long word. And pretty much if we break it down, it means body, embodied, and cognition and thinking about it. And in reference to this morning, the guest speaker was mentioning about Piaget and how it's really all one in terms of the movement and also the brain. So we have found in working with students that often, if we can tie in the two together, outside play, and we'll have a grid mat for you to experience in just a bit, but moving the whole body to count, that it really makes a difference. So here's a quote that I just want to summarize for you. Perception and action are inseparable in live cognition, and every act is an act of cognition. So as the children are thinking about how they're moving their body, and we were mentioning this morning about jumping jacks. Have you asked your children to do jumping jacks? Right? There's something about the timing and the coordination of it all. But once they get it, they really do have it. Or asking them to skip. Cute, isn't it? But it's the timing of their bodies and having it become the same thing. That's the whole movement, and that's what we're trying to have the children do.
So another piece of spatial reasoning is visualization. So if you think for a child, they're doing hands-on manipulatives. Maybe they're making a square out of some straws, some pipe cleaners, right? They're using their body to also do that. Then comes along visualization. And so for visualization, the key is basically for them, out of all their experiences, to have that visual in their mind. And that visual then turns into an image that is always there. And so for instance, for puzzles, they're making, say, a 24-piece puzzle, maybe a 12-piece puzzle. And they have a corner piece in their hand. And for embodied cognition, they're going to place that in the middle. And they got to kind of move it around, right, to see if it fits. Well, they don't have that visual in their mind yet. Maybe through those experiences, the next time they pick up that corner piece and they go, oh, I don't even need to move that there. I know it's a corner piece because I have that visual in my mind. I can see it. So I'm going to go straight to the corners. So that the visualization plays a huge part into spatial reasoning. And with visualization, the key is for people to have that image in their mind and to mentally rotate it, move it, flip it, manipulate that visual in their mind. And so with the pattern blocks, we all have pattern blocks in our classrooms, and for them to know that, you know what, I can see that trapezoid, and I know to flip it the other way to make it fit. And so with that visualization comes that problem solving, that critical thinking, like we said earlier. You know, you're making that whole brainstorm in your mind. And that's all spatial because of that visualization. Okay, so we're just about done talking, and we're actually going to do some rotations. And so before we begin, I just wanted to do a shout out to the online participants. If they look at this link right here, aimsedu.org/aimspatial, that's going to take them to 3 different videos. And the 3 different videos are videos with children doing the activities that we ourselves are going to do here. The only video I don't have of children doing is the Snap Cubes activity, and that's right here in the middle. And so online participants, if you want to watch those videos, there's some questions afterwards. If you can tweet out to us your reflection or any questions you have. And then if you want to come back in and just take a look at the Snap Cube activity right here. And so I'll go ahead and explain the activities first. And so we have a grid, which is on our mat right here. So right here is our mat. It's from a tarp. I got it at Walmart for like $1.14. And we had some tape, and we just taped off with a ruler. We use these mats in our preschool classes that we work with, and we work with the teachers also, and it's all about that language aspect in spatial and that directionality and the communication. We have the children do it, and basically they have a goal in mind. We want the child to have the goal. I want to get to that red number 3. Okay, perfect. Your partner's going to tell you how to get there. And so maybe the child's over here. And so Wilma will actually be right here at this activity. The next one is the snap cubes build, which is this table right here. This we have not done with our preschoolers, and you'll see why. And so you have bowls with snap cubes. All the snap cubes are the same color and same amount. And then you have file folders. You're each going to put a file folder up as your barrier, and you're going to have your bowl of cubes. You're going to have a partner. One person will be the builder. You're going to use those cubes to build a contraption. Then you are actually going to communicate to your partner and tell them how to build the same thing. You cannot look at theirs and say, nope, you just put that in the wrong spot. Can't look, and they cannot look at yours. So the emphasis at this station is really that language component. So that's right here. Count my moves. Count my moves is right here in front. And these are things that we use at our Ames Center of Math and Science, and we have 2 dice with finger patterns and pips. And then we have these cards, our Count My Moves cards. These are pictures of our preschool kiddos. And then on the bottom of it, it gives a description. This is our Embodied Cognition station. So you can roll 2 dice, you can roll 1 die if you'd like. And then the children, we'd like them to pick their card themselves because that's their goal. They got to choose, and so they're more engaged. And for their number count, their quantity to match their movement. And just like that jumping jacks, that gross motor skills, this is a good one. And then I was thinking of Kevin's presentation right now, right before us, that social emotional, how monumental are games for kiddos to learn those social and emotional skills, just taking turns. That's huge. So that's at this station. And then this one over here are pattern blocks. And we have wooden templates over there, and you're just going to build. Thank you. You're going to build with the pattern blocks. While you're there, keep in mind for yourself if you do lots of turning, rotating, or flipping. Just kind of jot that down in your mind. So we have 4 rotations, and we'll do 4 groups, and then we'll rotate every 6 minutes or so. And then the online participants will be coming in and out or watching the videos themselves. Does that sound all right? And then we'll talk about it and do a little recap. Okay?
And the wood templates you can use, like for instance, the hexagon. You can use the 1 yellow hexagon, or you can be creative and use 2 trapezoids. So there's different ways of putting that together.
Okay,
Great.
So let's go ahead and get in just to 4 groups. If you ladies wouldn't mind joining a group, that'd be awesome.
So I think I counted off. You can probably get in groups of 4, 3 or 4 each. And we'll rotate clockwise, yes.
Okay, go ahead and get started, and we'll give you the cue when we're going to rotate.
And I can take a group here. So, and then after that, they would pair up and then give directions on how to get to that. So that's one way of how to get to the number 6.
Okay, let's go ahead and start to clean up. I know. We have to go back to our original seats because we only have 5 minutes to wrap this all up. Don't worry about cleaning. I can do that afterwards. Oh, go ahead and have a seat. We're going to take like a couple minutes to wrap it up. Does anybody want to shout out real fast about the snap cubes? What they thought was great about this activity right here? Following directions, yes. And remember I said we haven't done this with our preschoolers, right? How about that language component? Major there, right? Mm-hmm. And then how about pattern blocks? We had a lot going on pattern blocks. Amazing. Yes, we had a good time over there. And that rotation and that flipping. I can't remember who I was talking to about DRDPs. Looking for your spatial. And and making those observations. Because for the progression, for the visualization, a child will slide objects, then they will rotate, and the last step is that flip. And so you can see, you can observe where they are for their level with manipulating those objects. They go right to rotating. Once they have those more experiences, they'll start to flip. And then throughout all these activities, the count my moves, that embodied cognition, your body movements with your count. And so easily, right, these can be thrown, all this can be thrown into your classroom. And then I think after Kevin's speech, we keep going back to that emotional and social development, playing the game, taking turns, encouraging each other. And then how about this mat right here? Did you guys enjoy that one? See the spatial in it, that directionality, your location, how many steps, that communication is always a huge aspect.
Hey, so we want to thank you and our online audience for participating with us.
Do you have the clicker?
Nope. Nope.
Let me click.
No, no. Oh, that's okay. Does looks different. Okay, so we're, as we mentioned, from the AIM Center for Math and Science, and we invite you to go and follow us on our blog. Each one of us has a blog. The early math team comes out with one every week on Mondays. So there's the www.aimsedu.org. Our blog, you can just find it on the link. We also have podcasts, not just of local educators, but we also have it of national and now international researchers. And it's just very quick, easy, and informative podcasts. Also, too, once a month during the school year, so beginning in August or September, on the fourth Monday of every month from 4:30 to 6, we have colloquiums, which is basically informative meetings. For 90 minutes, we'll have guest speakers. So there's lots of ways that you can still continue your excitement with early math and learn about it.
And then feel free to contact any of us. If you went to the mathematical play one earlier, those are our coworkers as well. Here's our information. It should be on the slide handout as well. Contact us. We can just pour information onto you. Okay? And then you can give us a tweet, questions, comments. We'll answer you today, tomorrow.
So with that, have a great weekend. Thank you, and remember to do the math. Enjoy the rest of your summer.
And thank you to our online people. Thank you.